The following is for 2008 Math 115 Department Final Version 3. Number 6. How much pure water must be mixed with 6 pints of 70% developer to produce a mixture that is 40% developer? That's the question is how much pure water. First step, let X be the amount of pure water. The second step, I will create a table. Since this is a mixture problem, now even though you in the real test you may not want to do the table, which I think is okay, it's possible, but it does require a certain maturity level for you to skip this one step here. In other words, do that only if you have very good experience, not very good intuition. Intuition is not a good guide. We have two types, the pure water and 70% developer. Now in the end, the one that you want to produce is the 40% developer. Okay, that's the resulting one here. Now this is the amount of pure water and 70% developer. This is the concentration, and this is the amount of developer in those things. Now the amount of pure water is the one we're looking for, that's our X. The amount of 70% developer is 6 pints. Now if you mix these two ingredients here, pure water and 7% developer, then you will have X plus 6 pints of the mixture, right? If you add those two, you get X plus 6. Now I think what usually confuses a lot of students is what is the concentration of developer in pure water. In pure water, if it is pure water, then there should not be anything else inside that water, right? In other words, the concentration of developer in pure water should be 0%. In decimal, that's 0. Now the 70% developer, the concentration of developer in there should be, as you guess, is 70%, or in decimal 0.7. Now the concentration that we expect to get after you mix this pure water with 70% developer, the goal is to create the concentration of 0.4. Now remember, in this table you can only add the second column, the amount, and the developer, the last column. Okay, the third column you don't add. Let's see, the developer, if I multiply this, the amount of developer in pure water is of course 0. What is the reason we call that pure water, right? And then in the 70% developer, if you have 6 pints, then you have 4.2%, 4.2 pints of pure developer. Now the one we want is this, the product of 0.4 times X plus 6. This is supposed to be equals to the sum of developer in those two things there, which is 4.2 only. In my step 3, that's the thing I need to solve. Okay, in my step 3, this is the thing I need to solve. Let me copy that down. Zero 0.4 times 6. 4 times 6 is 24, 1 decimal place. Then I subtract both sides by 2.4. I believe that's 1.8. And then I divide by 0.4, move the decimal place use, I get 9 over 2, which in mixed number, that should be 4.5 pints. Okay, so lastly, so the amount of pure water is 4.2 pints. Of course, in your real test, don't do this anymore. Just look at the answer, right? Okay, and of course, in the real test, try your best to master and experience this such that you don't need to put in too much detail. But I recommend you do not skip step 1. Okay, try your best to have enough time to do step 2 and step 3. Of course, you don't need to put too much detail like that. Step 4, once you remember the x is the amount of pure water, then you don't need to write this down anymore. Just go on with the options, and we know the answer is B in this case. Okay, that's for number 6. Number 7, solve this inequality. Now what I will do first, open the parentheses. There will be x minus 4 plus x plus 6 greater than 0. That's 2x plus 2 greater than 0. I subtract 2 on the other side. 2x is greater than 0 minus 2, which is negative 2, and I will divide by 2. Notice that even though I divide a negative number, I am not dividing that negative number by a negative number. You only need to reverse the sign if you divide by negative number. In this case, you divide by a positive number. That's why you don't need to change or reverse the sign. X is greater than negative 1. Okay, now let's put more details. If I need to graph this inequality, this x, let's have negative 1 somewhere here. This x is greater than negative 1, strictly greater than negative 1. So we know that we will shade the right hand side of that negative 1, and because you don't have equal sign there, it's strictly greater, then you can use a parenthesis opening to that side, to the right hand side. Okay, or sometimes in old time or some textbook actually use the open circle or closed circle way to show the word. Here, because it doesn't include the negative 1, it doesn't include the boundary negative 1, then I use open circle. Okay, this is from fall 2008 Math 115 Department Final, version 3, number 6 and number 7.